This episode of The Deep Dive is brought to you by Mindful Moments. Nourish your mind on the go. A series of AI-narrated meditations designed to feed your intellect and challenge conventional wisdom.
Yes.
Each bite-sized episode is packed with thought-provoking ideas, surprising facts, and insightful analysis, all designed to spark your curiosity and expand your understanding of the world. Wow, have you ever just stopped and thought about how unbelievably vast the universe is? I mean, billions upon billions of galaxies, each with billions of stars.
It really puts things into perspective, doesn't it? It makes our little world seem pretty insignificant in the grand scheme of things.
It does. It kind of makes those everyday problems feel a lot smaller, too.
Absolutely. But thinking about that scale, about all that's out there, it also raises some pretty big questions, doesn't
It
it?
sure does. Like, in all that vastness, all those stars and planets,
Yeah.
is there life out there besides us?
It's the ultimate question, isn't it? And, it's something that's really captured the imagination of scientists and philosophers for centuries. Even Carl Sagan, in the material you sent over, he argued that the possibility of life beyond Earth is one of the most profound questions we can ask.
And it's not just a scientific question either, right? I mean, it touches on some really fundamental things about who we are as humans and our place in the universe.
It really does. It makes you question everything. And the sources you shared, they offer some fascinating perspectives on this very topic.
Okay, so I know we can't definitively say yes or no to the question of extraterrestrial life, but what we can do is explore the possibilities.
Exactly. And that's what we're going to do today. We're going to delve into the scientific reasoning based on the information you provided that leads us to consider life beyond Earth, how it might emerge, how it adapts, and the potential for it to exist in ways and in places we might not immediately imagine.
Sounds good. So where do we even begin with something as big as this? I mean, how do we even define life in a way that makes sense in this context?
Well, one of the key definitions presented in your material describes life as essentially a molecular system capable of replication, mutation, and then replicating those mutations, which leads to evolution by natural selection.
So it's like a molecular machine that can copy itself and also make changes, errors even, as it copies.
Precisely. And those errors, those mutations, they get copied too, leading to variations and changes over time. It's this process of replication with variation that drives evolution.
That's fascinating. So we're not necessarily talking about little green men here, are we? It's much more fundamental, much more about the basic chemistry and processes going on at a molecular level.
Absolutely.
Right.
And when we consider the chances of such molecular systems arising elsewhere, one encouraging aspect is that the building blocks of life, those organic molecules, seem to be incredibly common.
Oh, really? Tell me more about that.
Well, scientists have conducted experiments simulating the conditions of early Earth and even the atmosphere of a giant planet like Jupiter. And you know what? They found that organic molecules, the essential ingredients for life as we know it, form relatively easily under a surprisingly diverse range of conditions.
So these complex molecules, they're not some sort of rare fluke.
Not at all. And it's not just in labs either. Radioastronomical studies, which are basically telescopes that listen to radio waves from space, have detected organic molecules all over the place. Out in interstellar space, in the vast clouds of gas and dust where stars are born, they're finding these molecules in abundance.
Wow, so the ingredients for life, they're kind of everywhere.
It seems that way. And here's another interesting point from your sources. When astronomers analyze the light from distant stars and galaxies, a process called astronomical spectroscopy, they find the signatures of familiar atoms and molecules. Carbon, nitrogen, oxygen, silicon, the very elements that make up life on Earth.
So we're not made of something unique. We're basically composed of the same stuff that's all over the universe.
Exactly. It's really quite humbling, isn't it? We're all connected in a very literal sense to the cosmos. Even magnesium carbonate, the stuff that makes up mountains like the Dolomites here on Earth, has been found in interstellar space. These are the elements that get incorporated into new solar systems as they form.
It's amazing. Okay, so we've got the building blocks. But what about the environment? We tend to think that you need an Earth-like planet for life to exist. With liquid water, a nice temperature, and atmosphere.
That's a natural assumption. But the material you shared challenges that notion. Life on Earth itself shows remarkable adaptability. I mean, think about it. We've found organisms living in incredibly harsh environments.
Like
Well, how about the crushing pressures of the deepest ocean trenches, or the freezing cold, oxygen-thin air at the summit of Mount Everest? There are even microbes that thrive in concentrated sulfuric acid, in the dry valleys of Antarctica, and inside tiny pockets of water trapped in salt crystals.
That's incredible. So life is a lot tougher than we give it credit for.
It really is. And your readings also point out this interesting idea of specialization versus generalization. Organisms that are highly specialized to a very specific environment can be very successful, but if that environment changes, they can quickly go extinct. Whereas organisms with more generalized traits might have a better chance of surviving change.
So being a jack of all trades can actually be an advantage in the long run, especially if you're thinking about life on other planets where conditions might be quite different.
Exactly. Take Mars, for instance. With its thin atmosphere and weak ozone layer, the surface is bombarded with intense ultraviolet radiation. But life there could potentially adapt, developing natural shields or molecules that are opaque to UV light.
So Martian life with built-in sunscreen. I like that. What about extreme temperatures? I mean, we often think of planets like Jupiter and Saturn as being far too cold to support life.
True, but remember, those gas giants have really deep atmospheres. And as you go deeper into those atmospheres, the pressure increases, and so does the temperature. There are likely regions within those atmospheres where temperatures could be quite comfortable for life as we know it.
So just because it's freezing at the cloud tops doesn't mean it's uninhabitable further down. That's fascinating. And speaking of life as we know it, the material you shared also talks about why carbon is likely such a fundamental element for life, perhaps throughout the universe.
Yes, carbon is a very versatile element. It can form incredibly complex and stable molecules, both with itself and with other elements. And this ability to form complex structures is essential for life as we understand it.
And we know carbon is abundant, right? I
Mhm.
mean, it's one of those common elements in the universe.
Absolutely. And it's readily available in the very environments where life is thought to originate, like those interstellar clouds we were talking about earlier. The fact that we see so many organic molecules, which are carbon-based, both in our experiments and out in space, suggests that carbon-based life might be a common theme.
Okay, so based on what we discussed so far, we've got the building blocks, we've got evidence of life's incredible ability to adapt to a wide range of conditions. This leads us to some of the more positive theories about life elsewhere and where we might actually find it.
It's a thrilling prospect, isn't it? And it encourages us to think beyond simple Earth-like scenarios. Life on other planets might have evolved along entirely different paths, leading to forms we can't even imagine.
And we're actively searching for it, right? Like with projects like SETI, the search for extraterrestrial intelligence.
Exactly. Projects like Project Ozma, which specifically targeted nearby stars like Tau Ceti, are examples of our efforts to detect radio signals that might indicate the presence of technological civilizations. The material you sent even mentions this.
Sending out a cosmic hello and listening for a response. It's such a hopeful endeavor. But what about some of the more unconventional ideas about where life might exist?
Yeah.
I mean, your sources mention things like interstellar space and even the surfaces or interiors of stars.
Those are definitely more speculative ideas, but they're worth considering. The main challenge with interstellar space, as highlighted in your readings, is the incredibly low density of matter. It would be difficult for life to acquire enough resources to replicate and thrive in such an environment.
So it's not impossible, but it's definitely a long shot.
Perhaps. But the idea of intelligent beings, perhaps originating on planets like ours, but eventually expanding their activities into interstellar space in the far future, that's a more compelling possibility that your sources raise.
So civilizations so advanced that they can essentially live among the stars, harnessing the matter and energy of entire galaxies. That's mind-boggling.
It is, and it really underscores how much we still have to learn and how limited our current understanding might be. This kind of exploration, trying to grasp the vast potential for life beyond Earth, reminds me of the work being done by channels like Mindful Moments and our podcasts on YouTube. They use AI to analyze audiobooks and uncover fascinating insights. It's another way to engage with complex ideas and maybe spark new ways of thinking.
I'll check that out. Okay, so even finding something as simple as microbial life on another planet, like Mars, would be huge, right?
Absolutely. As your sources point out, the discovery of any kind of extraterrestrial life would have a profound impact on our scientific understanding, our technology, and maybe even our philosophy. It would be one of the most significant events in human history.
And even finding simple life on Mars, the text says, would be a huge boost to biology.
It would. It would offer us a unique opportunity to study life that arose independently of life on Earth. We could compare and contrast, trying to understand the fundamental processes that lead to life's emergence. It would be an incredible natural experiment.
It really is amazing to think about. So this whole discussion, this deep dive into the possibility of life beyond Earth, based on the information you shared, it's not just about aliens and distant planets, is it?
No, it's not. It forces us to reconsider our place in the universe, to reevaluate our assumptions about life itself. And it also makes us appreciate the unique, but perhaps not entirely singular nature of life on Earth.
So let's do a quick recap. We started by defining life, not just as complex organisms, but as a fundamental process of molecular evolution, drawing from your sources. We saw that the building blocks of life were surprisingly common, scattered throughout the universe.
We then explored how incredibly adaptable life is, using examples from right here on Earth, organisms thriving in conditions that seem impossible. And this adaptability suggests that life elsewhere could be far more diverse than we can even imagine.
And we even touched on some of those more mind-blowing possibilities. Life in interstellar space, civilizations harnessing the energy of stars, all based on the information you provided.
And the key takeaway is that the search for life beyond Earth, no matter how simple or complex, has profound implications for our understanding of biology, our place in the universe, and the future of humanity, as emphasized in the material you shared.
It's really awe-inspiring when you think about it. If life can flourish in so many incredible ways on our own seemingly ordinary planet, what unimaginable forms might it take out there in the vastness of space? Shaped by billions of years of evolution under completely different conditions. It's a truly humbling and exhilarating thought.
A thought worthy of much deeper exploration, wouldn't you say?
Absolutely. And for anyone listening who found this conversation as fascinating as we did, we encourage you to subscribe for more explorations into thought-provoking topics. Share this with anyone you think might be interested, and you can purchase via the link below for more related content. Most importantly, keep thinking critically about the information presented here and the ongoing quest to understand our place in the universe.